So, for us to be able to connect them, one way is to weld them, yung ends nila dun sa may gasket plate. Okay, parang ito yan. For sure, nakikita nyo to sa mga bridges and so on. Okay, so planar trusses lie in a single plane and are often used to support roofs and bridges. So roof trusses are often used as part of an industrial building frame, and ito, roof trusses, kadalasan nakikita natin yan sa mga bubong natin kung may bubong tayo. Siyempre, walang roof truss kapag roof deck, tama ba? Okay. So the roof load is transmitted to the truss at the joints by means of a series of purlins. So ito yun. Yung mga purlins natin. Okay, so commonly yung mga roof trusses talaga sa mga industrial building frame, mga warehouse. Kaya kapag nagde-design tayo or nagko-compute tayo, naalala nyo sa statics nyo, so meron kayong roof truss or meron kayong truss. Okay, so meron dito, and then ganyan. Tapos may mga load kayo dito na perpendicular sa kanya, meron din dito, and so on. Meron din minsan dito. Kasi minsan, meron tayong ina-attach mismo dun sa may framing natin. Okay, so to keep the bent rigid and thereby capable of resisting horizontal wind forces, knee braces are sometimes used at the supporting columns. So ito yung mga common types ng roof trusses kung naaalala nyo. Tama ba? Kayo ba yun? Yung pinag-ano ko ng trusses, tama ba? Truss. So depende kung anong gusto nyong type ng truss, no? So, and actually, di ko ito kabisado, no? May scissors, truss, faux truss, Pratt, fan, fink, cambered fink, and so on. Actually, madami yan. Warren. Yung Warren yung pinaka-common sa mga bridge yata. And then, sawtooth, bowstring, and 3-hinge arc. Itong 3-hinge arc, madalas na lumalabas sa board exam. Okay? So, yan. So, the main structural elements of a typical bridge truss are shown. So, ito yung common elements ng bridge natin. Okay? So, meron tayong floor beam, ito. And then, we have the yung portal bracing, ito. Portal bracing, ito. Lateral or top lateral bracing, ito. Medyo hindi lang siya visible yata dito. We also have the top cord, ito. And then the bottom cord, itong nasa ilalim yata. And then the deck, ito. Okay. So, ito yung mga kadalasang ginagamit sa bridge, itong type ng mga trusses na nasa screen nyo. Okay. Now, for assumptions for design sa mga trusses, so first, to design both the members and the connections of a truss, it is first necessary to determine the force developed in each member when the truss is subjected to a given loading. So in this regard, two important assumptions will be made in order to idealize the truss. So the members are joined together by smooth pins. So in cases where bolted or welded joint connections are used, this assumption is generally satisfactory provided the center lines of the joining members are concurrent at a point. Actually, itong mga assumptions na to na nakalagay dyan, nasa PDF nyo rin, actually ito yung ginagawa nyo dati sa statics. You have there two methods na kinokondak method of joints and then method of sections. Naalala nyo pa? Yes. So, medyo matrabaho yung dalawa, no? Lalo yung method of joints. Lalo na kapag sobrang daming members, sobrang daming joints nung truss nyo, talagang aabot kayo, di ko alam kung umabot na kayo ng mga 3 pages, kakasod ng sa method of joints. Kasi per joint yung analysis. Whereas kapag method of section, nagiging advantage lang yung method of section kapag mayroon lang specific member na pinapahanap. Well, for member B, determine the actual force. Actual force, ibig sabihin yung force nung member na yun, internal force ng member na yun. Medyo hassle kapag magme-method of joins ka pa, lalo't malayo siya sa support. Tama ba? Kasi di ba nag-start kayo sa support reaction? Tama ba? So, kung naalala nyo, may mga proof din kami dati na malakas yung trip, sobrang daming members, tapos magpapahanap sila ng joint, yung banda malayo sa yan, papahanap niya to, yung medyo malayo talaga sa may support reaction. So, kapag ganun lang kasi yung pinapahanap, better na wag ka nang mag-method of joins kasi matrabaho. Tama ba? So, mas maganda method of section na lang tayo dyan. Okay? So, yun. We also have this classification of coplanar trusses. We have the simple truss, the compound truss, and yung complex trusses. So, kapag sinabi nating simple truss, the simplest framework that is rigid or stable, or the simplest framework that is rigid or stable is a triangle. Once na maka-form ng triangle yung ating truss, masasabi na natin na simple truss na siya. Yun yung kasi yung basic requirement sa simple truss, as long as dapat maka-form siya ng triangle. So consequently, a simple truss is constructed by starting with the basic triangular element. So yun na nga. And then another simple truss is constructed as shown. So for this method of construction, it is important to realize that simple truss do not necessarily consist entirely of triangles. So parang tulad nito. Ito, figure 1, figure 2, and figure 3, examples ng simple truss. So kung makikita nyo sa figure 3, yung ito, hindi naman siya triangle, no? So not necessarily naman na dapat triangle. Okay? Hindi nyo pwedeng insist na hindi dapat triangle yan. Pag hindi yan triangle, hindi yan simple truss. Okay? As long as nandoon yung main simple truss. Okay? So, ayun. Makakonsider na siya as simple truss. And then for compound truss, so ito medyo na naguguluhan din ako sa compound at saka sa simple kasi kung makikita nyo yung letters, figure 1, figure 2, figure 3. Okay, so dito actually, yung kaninang figure parang ito pwede na to as compound pero according to the reference, simple truss pa rin daw siya. Okay, so dito naman, yung figure 1 natin, yan daw ay makakonsider na compound truss kasi ang sabi sa compound truss, dapat daw connected by 2 or more simple trusses. So, ibig sabihin, kailangan maka-form ka muna ng dalawa, at least dalawang simple truss dun sa isang system natin. So, dito sa unang figure, ang unang simple truss niya, ito, and then yung pangalawang simple truss niya is ito. And then itong BE ba to? Yes, itong BE nagsiserve as parang link or connection dun sa dalawang simple truss natin. And then sa figure 2, same din. Ito yung simple truss natin. Una, yung malaki. And then yung pangalawang simple truss, ito, yung maliit sa loob. Okay? And then, so meron tayong dalawang simple truss. And then, yung nagko-connect sa kanila, ito, EC, AD, BE. Gets? Now, masasabi daw na complex truss kapag hindi siya nag-qualify as simple and compound. Okay? So, actually ito, kanina binabasa ko siya, medyo nalilito pa rin ako kung paano mag-differentiate ng simple sa compound kasi yung simple kanina parang compound na siya para sa akin. So, nag-search pa ako ng iba, other examples ng simple compound truss. Ito, same lang din ng kanina, So, yan yung pinaka-explanation niya, parang, yung shaded part, yun yung consider as simple truss and then connected by a pin dito and then a link dun sa ilalim. Ito naman, consider as compound truss pa rin siya kasi meron ka ditong dalawang simple truss. Yung naka-shaded part, yun yung simple truss. and then connected by a link. Ito. Tatlong link actually. Ito, and ito. Next is ito. Same pa nung kanina, no? So, ito daw ay compound truss kasi yung isang buong triangle, yung malaki, and then yung maliit na triangle sa loob, yun daw yung dalawang simple truss natin, connected by 3 links. Ito, at saka ito. Okay? Okay, next. So, for determinacy of trusses, ito yung same na dun sa beams natin or sa frames. So, for any problem in truss analysis, it should be realized that the total number of unknowns or total number of support reactions includes the forces in B or ito yung number of bars dun sa truss natin, sa truss system, and the total number of external support reactions R. And then consequently, rotational or moment equilibrium is automatically satisfied at the joint or pin. And it is only necessary to satisfy the summation of forces along x be equal to 0 and the summation of forces along y be equal to 0 to ensure translational or force equilibrium. So ito yung sinasatisfy natin equation. Una, okay, B plus R is equal to 2J. Yung B, again, ito yung number of bars. Okay? Yung R, ito yung number of support reactions. And then yung J, ito yung number of joints. Now, kapag yung sum ng B and R ay equal sa 2 times the number of joints, masasabi natin siya na statically determinate. Okay? Next. Kapag ka daw yung sum ng number of bars and support reactions ay mas malaki sa 2 times the number of joints, masasabi natin siya na statically indeterminate. Siyempre, kapag indeterminate siya, ini-indicate natin yung degree of indeterminacy. Tama? Pwede siyang statically indeterminate to the first degree, to the second degree, and so on. Now, kapag mas malaki naman yung 2 times nung number of joints dun sa sum nung number of bars at number of support reactions, doon na natin siya masasabi na unstable. Okay? So, in particular, the degree of determinacy is specified by the difference in numbers of nung B plus R and nung 2J. Okay, so if B plus R is less than 2J, so a truss will be unstable. Okay, yes, kasi yun yung sinabi natin kanina. Ito. Equation 3. That is, it will collapse since there will be an insufficient number of bars or reactions to constrain all the joints. Okay, so also, a truss can be unstable if it is statically determinate or statically indeterminate. So in this case, the stability will have to determine either by inspection or by force analysis. So take note of this, a truss can be unstable if it is statically determinate or statically indeterminate. Ibig sabihin, pwedeng yung truss natin statically determinate siya pero unstable. Pwedeng yung truss natin statically indeterminate pero unstable. Okay, so paano yon? Kapag sinabi nating, or meron tayong dalawang kinoconsider dyan, external stability and yung internal stability. Yung structure natin or yung truss natin ay masasabing externally unstable. Okay, externally unstable kapag yung lahat ng reactions ay concurrent or parallel. Ulitin natin. Yung structure or yung analysis ay masasabi nating externally unstable kapag yung reactions ay concurrent or parallel. Ano kapag sinabing concurrent ulit? Ito yung kapag nag-meet at one point yung ating mga reactions. So dito sa unang figure natin, nasaan yung point of intersection nung support A? Nandito. Tama ba? Now, saan papunta yung support reaction natin sa B? Papunta dito. Tama ba? So, ibig sabihin, yung points or yung line of axis ng reaction ng point A at point B ay magmi-meet at one point. Ibig sabihin, concurrent sila. So ngayon, by inspection, masasabi nyo na yung ating structure ay externally unstable. Okay, so yun yung classification para masabi na externally unstable siya. Now, kapag hindi naman nag-meet at one point yung reactions natin, meaning lahat ng reactions, kung meron kayong 3 or 4 na reactions, dapat lahat yon. Okay, so kapag lahat ng reactions natin ay nag-meet at one point, ibig sabihin concurrent, externally unstable. Pero kung hindi lahat nag-meet at one point, masasabi natin na externally stable siya. Okay, next, internally stability. The internal stability of a truss can often be checked by careful inspection of the arrangement of its members. So if it can be determined that each joint is held fixed so that it cannot move in a rigid sense with respect to the other joints, then the truss will be stable. Internal stability. Wait. Then, so notice that a simple truss will always be internally stable. Yes. So since by the nature of its construction, it requires starting from a basic triangular element and adding successive rigid elements, and each containing 2 additional members and a joint. Okay, so asan yung isang explanation niya? So to determine the internal stability of a compound truss, it is necessary to identify the way in which the simple trusses are connected together. So for example, asa yung example niya dito? Wait. Figure 1, figure 2, figure 3. Okay, so wait lang, hanapin ko yung example niya dito. Ito, okay. So for example, the compound truss as shown is unstable since the inner simple truss ABC, asan yung outer niya? ABC, inner simple truss, ito yun. ABC, okay? The inner simple truss ABC is connected to the outer simple truss DEF. Ito yung DEF. DEF. Okay? Using 3 bars, AD, BE, and CF, which are concurrent at point O. Thus, an external load can be applied to joints A, B, or C and cause the truss ABC to rotate slightly. So, dito makikita natin na masasabi natin siya na internally unstable siya kapag yung ating members ay ang tawag dito? Yung members natin ay mag-connect or pwedeng yung line of axis yon. Yung line of axis ng ating members, ito, yung connectors natin, A, D, B, E, and C, E. So kung makikita nyo, mag-meet sila at a certain point dun sa point O. Okay. So kapag nag-meet daw yung ating members, kasi yung actual force ng A, D, B, E, and C, E, tama ba? CF pala rather. CF ay mag-meet at a certain point, doon natin masasabi na yung stress natin ay internally unstable. Pero kapag hindi sila nag-meet, so masasabi natin na yung stress natin ay internally stable. Okay, so for another example, okay, so the instability of any form of truss, be it simple, compound, or complex, may also be noticed by using a computer or sinasabi niya dito software to solve the 2J simultaneous equations written for all joints of the truss. So dito, kapag yung B plus R daw ay less than 2J, ito yung figure natin or ito yung equations natin kanina, unstable yung ating truss. Okay, yes. Now, yung B plus R, which is pwedeng greater than or equal sa 2J. Tama ba? Yung greater than, ito yung indeterminate. Statically indeterminate. Kapag equal naman siya, ito yung determinate. Tama ba? Now, kapag yung B plus R daw ay greater than or equal sa 2J, unstable daw yung ating unstable yung ating structure given that if the truss support reactions are concurrent or parallel. Nasundan nyo ba? Ang ibig sabihin niya dito, hindi porket equal yung B plus R dun sa 2J, masasabi na natin agad na determinate. Yes, determinate siya, pero i-make sure pa natin kung stable ba siya or unstable. Gets? So, ibig sabihin niya dito, okay, sige, hanapin mo kung statically indeterminate or statically determinate. Next step, check mo kung unstable or stable. Unstable kapag yung support reactions, katulad nung kanina, yung support reactions, roller, ay concurrent. Pag sinabing concurrent, ito yung reaction, mag-meet at a certain point, concurrent. Parallel kapag ay roller, okay. Parallel siya kapag ganito. Kung makikita nyo, yung forces, yung reactions ay parallel sa isa't isa. Okay? So, yun lang. Basta hindi siya concurrent at hindi siya parallel, stable yung ating structure. Okay? Sige. So, try natin to. So, dito sa unang example natin, we have here, sa point A, roller. Sa point B, tama ba? Hinge? Yes, hinge. So, since the reactions are not concurrent, paano natin nasabi na concurrent? Yung reaction natin sa point A ay paganito. Tama ba? I-correct nyo kung mali And then yung reaction natin sa B ay paganito at sabi natin paganito. Ganito na lang. Sige. Okay. Now, question, yung reactions ba natin ay concurrent? Yung reactions ba natin ay nag-meet sa isang point? Yung lahat ba ng reactions natin ay nag-meet sa isang point? Hindi. Okay, yes. So, non-concurrent. Tama ba?
Hindi.
Non-concurrent. Next, yung reactions ba natin, lahat ng reactions ay parallel sa isa't isa?
Hindi po.
Siyempre, hindi. Non-parallel. So, ibig sabihin, masasabi natin na yung figure natin ay externally stable. Okay, so yun yung unang step. Next, identify natin ilan yung number of bars natin, number of members. Sige, pakibilang.
19.
19. Okay. Double check. 19 yung bars natin. Yes?
Yes po.
Yes, okay. Now, masasabi natin, another classification para masabing internally unstable siya, ito by inspection lang, dapat daw lahat ng joints nung truss system natin ay makaka-form ng triangle. Okay? So dito, kung ma-check natin, lahat ng joints natin ay naka-form naman ng triangle. So ito yung sinasabi nila na by inspection, the truss is internally stable. So pwede rin naman another, kung ayaw mo mag-inspect, pwede rin naman siya by software yata. Pero kadalasan by inspection, masasabi mo na agad na internally stable siya. Okay, so imagine, paano kung walang, ang tawag dito, walang member dito. Isipin nyo wala tong member na to, tsaka ito. So, pure lang siya na rectangle, tama ba? Now, kapag nag-apply tayo ng load dito, possible na mag-collapse yung ating structure dito sa member na to. Kasi hindi siya, tawag dito, hindi siya reinforce ng maayos. Okay? So, isa sa mga classification para maging stable siya, dapat lahat ng joints niya ay merong connection or merong or makaka-form siya ng triangle. Plus, dapat supported siya palagi ng isang member. Okay? So, next, dito sa example natin, sige, we have dalawang hinge, tama ba? Dalawang hinge. So, sige, sabihin natin pag ganito parehas. Okay. And ganito. Okay. Now, masasabi ba natin na siya ay externally stable or unstable?
Stable po.
Okay, stable. Stable siya kasi hindi concurrent yung forces natin at hindi parallel yung forces natin. Okay, kasi meron tayong, though merong dalawang parallel, ito at saka ito, pero kasi yung dalawa pang forces, hindi naman sila parallel dito. Tama ba? So, hindi natin masasabi na concurrent. Plus, though parehas ng line of action, itong reaction na to at ito, pero itong reaction na to at ito ay hindi naman ano tawag dito, hindi siya same line of action ng dalawang reaction na to. Okay? So, since the reactions are not concurrent or parallel, masasabi natin na yung truss natin ay externally stable. Okay siya. Sige, paki-compute or paki-bilang yung number of members natin.
14.
15.
14 po.
15 po. Ilan talaga? 14, 15?
14 po. 15 po. 15.
Sige, ilan talaga? 15?
15.
15. 15 daw, sige. Bilangin natin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Tama. 15. Okay, number of reactions, 4. Ilan yung number of joints natin?
9.
Okay, 9. Tama ba? Number of joints, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so yung B plus R natin, 15 plus 4, that is 19. And then yung 2J natin ay 18. So dito makikita natin na yung B plus R ay greater than 2J. Therefore, yung plus natin ay statically indeterminate. State natin kung ilang degree, that is statically indeterminate to the first degree. Okay, and then by inspection, internally stable or unstable?
Stable.
Stable.
Internally stable.
By inspection, the truss is internally stable. Okay? Question?
Wala.
Wala. Okay, sige. Next. Ito ay hinge. Tama ba? Hinge. And then ito ay roller. Okay? Sige. By inspection, or yes, by inspection, yung ating truss ba ay externally unstable or stable?
Stable po.
Okay, stable. Now, pakibilang, ilan yung number of bars natin?
15.
12 po. 12.
12. 12. Sure? Yes. Sige. Number of bars, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? Number of reactions, 3. Ilan yung joints natin?
8.
Sorry, ilan?
8 po.
8 po.
8. Okay, 8. 8, okay. And then, we have here, B plus R is equal to 15, tama ba? 12 plus 3, and then yung 2J natin ay 16. So, yung B plus R is less than 2J, tama ba? Kasi 15 lang to, and then ito ay 16. So, therefore, yung, ang tawag dito, yung truss natin ay unstable. Hindi ko na ilagay. Yung truss natin ay unstable, tama? And then by inspection, yung ating trust is internally unstable. Bakit unstable?
Kasi po,
Hindi po lahat nag-form ng triangle.
Hindi lahat. Sorry.
connected po siya sa may gitna. Tapos po siya.
Hindi po maayos ang orientation ng members.
Hindi maayos yung orientation ng members. Okay, ano pa?
Kulang po siya sa support. Sa may po, gitna.
Kulang sa members, sa may
Kulang
gitna.
ng members po.
Okay. So, kaya nasabi natin na internally unstable siya. Okay? Next. Anong type ng trust to? Simple, compound, complex?
Compound po.
Compound. Okay.
Compound.
So, dito sa figure natin, sige, paka-identify externally stable or unstable.
Externally stable po. Stable po.
Externally
Stable po.
stable. Okay. So, bakit externally stable? Ito yung reaction natin. And ito yung para sa roller. A, B. Okay. So, yung support reactions natin sa points A and B ay hindi naman nag-meet at a common point. So, masasabi natin na yung trust natin ay externally stable. Okay? Next. Ilan yung number of members natin?
9.
9 po.
9. Okay. Number of reactions? 3. Number of joints?
6.
6.
6 po. 6 po.
6. Okay. Tama ba? 1, 2, 3, 4, 5, 6. Okay. So, yung B plus R is equal to 12. Tama. 9 plus 3. And then, yung 2J natin ay 12. So, itong structure natin ay B plus R is equal to 2J. Yes. Equal silang dalawa. Therefore, yung trust natin ay statically determinate. And internally stable or unstable?
Stable.
Stable po.
Stable? Yes?
Yes po.
Yes, okay. Internally unstable. Now, meron akong figure kanina. Saan na ba yun? Ito. Okay. So, ito, try lang natin, no? Itong figure 3, tingnan ng figure 3. Externally stable or unstable?
Stable.
Stable po.
Stable po. Stable po.
Stable po, ma'am.
Internally stable. Okay. Number of bars, ilan?
9.
9 po.
9 po.
Sorry, ilan?
9 po.
Okay, 9. Number of reactions?
6 po.
3.
Po, 3.
Okay. Number of joints?
6
6
po.
po.
6. Okay. So, 9 plus 3, 12. So, 12. So, yung trust natin ay statically determinate. Tama. Okay, next. Ito ba ay internally stable or unstable?
Unstable.
Unstable.
Unstable kasi nakalagay po, ma'am eh. Internally unstable. Bakit unstable?
Concurrent lahat ng internal.
Bakit unstable? Sorry.
Concurrent po lahat. Nagmimix
Concurrent
sila sa
yung AD, yung BE, and CE. So, masasabi lang naman natin sila na concurrent kapag, syempre, nag-project tayo ng, ang tawag dito, or pre-project natin or in-extend natin yung line of action nung tatlong members na yun. Pero commonly naman sa mga given, ina-extend talaga nila yung line of axis para masabi natin or para makita natin na mag-meet sila at a common point. Minsan kasi sa mga problem, mukha silang mag-meet pero hindi pala. Okay, so may mga ganun eh. Meron naman, mag-meet ba to kasi parang hindi. Yung pala mag-meet sila. Okay? So ngayon, kapag kayong members natin ay nag-meet at a common point, commonly, yun nga, internally unstable siya. Okay? So, okay. For inspection, the trust is internally stable. Okay, now, I have here 6 figures. 1, 2, tama. And then, you have to identify kung yung trust natin ay externally stable or unstable. And then, kung stable man siya, you have to identify kung statically determinate or statically indeterminate and to what degree. And then, identify nyo rin kung internally stable or unstable. So, this one is for your practice problem. Okay, so ito yung i-work nyo for this day, and then by next week, tatawagin ko kayo isa-isa kung ito ba ay externally stable, unstable, statically determinate, indeterminate, and to what degree, and internally stable or unstable. Okay, so practice problem, hindi assignment. Okay, so wait. Double check ko lang yung ating classroom. Okay. Sige, so lahat naman ay nakapag-submit na. Okay, good. So itong mga assignment na ito, malaki yung maitutulong nito sa inyo, no? Sa inyong final rating. This is 5% din, no, ng rating nyo. Okay, so basta gumawa lang kayo ng assignment, gawa lang kayo ng gawa. So, ma-perfect nyo na lahat, at least have 5% in addition to your final rating. Okay, sige. Questions, clarifications? So, we're done with the synchronous class. Now, pupunta na tayo sa asynchronous part. Gusto kong i-work on nyo itong mga types ng trusses na to. And then, by next week, Monday, continuation tayo ng stability ng trusses. Actually, konting discussion na lang. And then, we'll proceed with the virtual work sa trusses. Okay, and then, continuation by Tuesday, virtual work. And then, by Friday, expect your quiz number 1. So, quiz number 1, ano lang siya? Online class, virtual lang. Kasi hindi pa tayo ina-allowed na mag-face-to-face exam. So, yung quiz 1 nyo ay online pa rin. Okay, sige. Paki-screenshot nitong part na to. Okay. Sige. And then, sige, paki-open ng cam.